Hello, today I will be explaining what a DHT11 sensor is, how to connect it to an Arduino UNO board and explain the code used for the DHT11 sensor. What is a DHT11 sensor? A DHT11 sensor is a digital temperature and humidity sensor that uses a single-wire communication protocol to send data to a microcontroller or other digital device. It's a low-cost, easy-to-use sensor that's perfect for a wide range of applications, from weather monitoring to indoor climate control. As you can see, a DHT11 sensor has 4 pins, VCC, GND, data, and not connected pin. There is also a 3-pin variant of the DHT11 sensor. In terms of functionality, both 3-pin DHT sensors and 4-pin DHT sensors work the same way and provide similar readings of temperature and humidity. But there are some advantages of the 3-pin DHT11 sensor are that it requires fewer pins on the microcontroller, which can be useful in projects. However, the 4-pin DHT11 sensor may offer more stable communication because the extra pin provides better electrical isolation between the sensor and the microcontroller. So the choice between a 4-pin and a 3-pin DHT11 sensor depends on the specific application and the available resources. Connect the VCC pin to the 5V pin on the Arduino, the GND pin to the GND pin on the Arduino, and the data pin to any digital pin on the Arduino. Since we are using a 4-pin DHT11 sensor, we will also need to connect a 10k ohm pull-up resistor from the VCC pin to the data pin. Once you have the DHT11 sensor connected to the Arduino UNO board, you will need to install a DHT library to read the temperature and humidity data from the sensor. Here's some example code that shows how to use the DHT library to read data from the DHT11 sensor. Within the red box it shows the library that we are using, as well as the definition of what digital pin is connected to the data pin of the DHT11 sensor and the type of DHT we are using. There is also a line of code that creates a DHT object, which is used to interact with a DHT sensor. Within the blue box it shows the setup. Serial begin initializes the serial communication between the Arduino board and the computer. Serial communication to 9600 bits per second. This is a common baud rate used for communicating with the Arduino board over a USB cable. DHT begin initializes the DHT sensor object that was created earlier in the code. This function initializes the communication between the Arduino board and the DHT sensor and prepares the sensor for reading temperature and humidity. In the yellow box, it shows the 2 lines of code that read the humidity and temperature data from a DHT sensor using the DHT object that was created earlier. The green box shows a if condition which reads the humidity and temperature. If the condition of the humidity or temperature is not a number, it will display a message saying that it failed to read from the DHT sensor. There is also a return statement at the end. This is used to exit the function and return control to the main loop of the program. This prevents the program from continuing with invalid sensor readings, which could cause errors or unpredictable behavior later in the code. In the purple box, it shows the lines of code that is used to print the humidity and temperature readings obtained from the DHT sensor to the serial monitor of the Arduino IDE. The serial print function is used to send data to the serial monitor over the USB connection. The F function is used to store the string literals in flash memory, which saves RAM space on the microcontroller. Here you can see the previous connection that we made earlier. As I put my hand over the DHT11 sensor, the humidity and temperature will rise. And when I take away my hand, you will see that the humidity and temperature will fall. The DHT11 sensor is very sensitive. As I gently blow in the direction of the DHT11 sensor, you will see that the humidity and temperature will rise. And as I stop blowing on the DHT11 sensor, you will see that the humidity will fall. That is all for today. With just a few lines of code and a DHT11 sensor, you can easily monitor the temperature and humidity in your environment. Thank you for watching this video.